Our seventh example is actually taken from a textbook, Additional Mathematics 8th edition by Te Keng Seng and Lo Cheng Yi, published by Xingli Publishers, exercise 6F number 20. We're required to solve 2 cosec squared x plus cot x minus 8 equals to 0 on the interval from 0 degrees to 360 degrees. Here we are meeting the other two reciprocal trig functions, cosec x and cot x. Cosec x is equal to 1 over sine x, and cot x is equal to 1 over tan x. Again, the question arises, is there a relationship that links cosec x with cot x? And again, the answer is yes. Recall the trig identity. Cosec squared x is equal to 1 plus cot squared x. If we make this substitution, we will obtain a quadratic equation in terms of cot x. So we replace cosec squared x with 1 plus cot squared x, and once we expand and simplify the left hand side, we will obtain the quadratic form. So we get 2 plus 2 cot squared x plus cot x minus 8 being equal to 0. And finally, putting it in the form 2 cot squared x plus cot x plus 2 minus 8 is equal to minus 6, and that is equal to 0. So we have obtained a quadratic equation in terms of cot x. This could be factorized. 2 cot x in the first bracket and cot x in the second bracket. We want to get back this minus 6, and of course once we expand the two brackets, the middle term must have a coefficient of plus 1. We will want to get back plus 1 cot x. So these two numbers would have to be minus 3 in the first bracket and plus 2 in the second bracket. So we get minus 3 cot x plus 4 cot x, giving us plus 1 cot x, and of course minus 3 by plus 2 gives us the minus 6. So once we expand these brackets, we will obtain 2 cot squared x plus cot x minus 6. Next we take the first factor, 2 cot x minus 3 is equal to 0, or cot x plus 2 may also be equal to 0. Solving the first factor, 2 cot x minus 3 equals 0 implies that 2 cot x is equal to 3, and therefore cot x is equal to 3 over 2. Now remember, cot x is the reciprocal function of tan x. So if cot x is equal to 3 over 2, then tan x is equal to 2 over 3. Tan x will be equal to the reciprocal of 3 over 2. So tan x equals 2/3. Our reference angle alpha is equal to tan inverse of 2/3, and that is equal to 33.7 degrees. tan is positive in the first and third quadrant, so we draw in our reference angle 33.7, 33.7 in the first and third quadrants. Of course, our solution for x in the first quadrant is x equals to alpha, which is, let's write that in black. X is equal to 33.7 degrees, or in the third quadrant, so I'll just draw this angle all the way around there. That's 180 plus alpha. So x is equal to 180 plus alpha in the third quadrant. That's 180 plus 33.7 degrees. So the two solutions for 2 cot x minus 3 equals 0 are 33.7, and this will be 213.7 degrees. These will be our two solutions for first factor. The second factor, cot x plus 2 equals 0, implies that cot x is equal to minus 2, which means that tan x is equal to the reciprocal of minus 2, and that's minus 1 over 2. Alpha is equal to tan inverse of a half. The absolute value of minus a half is plus a half. Tan inverse of a half is 26.6 degrees. This time tan is negative, so we are going to pick up solutions from the second and fourth quadrants, because that's where tan is negative. So we put alpha in the second and fourth quadrants, and then we pick up those two angles. So in the second quadrant, x is equal to 180 minus alpha. X is equal to 180 minus 26.6 degrees, and in the fourth quadrant, x is equal to 360 minus alpha. 360 minus 26.6 degrees. So x is equal to 180 minus 26.6 will give us 153.4 degrees, and 360 minus 26.6 will give us 333.4 degrees. So the full solution for 2 cosec squared x plus cot x minus 8 equals 0 is x equals 33.7 degrees, 153.4 degrees, 213.7 degrees, and 333.4 degrees. And those are the 4 solutions to our original equation. 2 cos x squared x plus cot x minus 8 is equal to 0 on the interval from 0 degrees to 360 degrees. Now, before this video completes, I just want to write down a summary checklist for you all. Things that you should know before you can solve any trigonometric equation. Just to be sure we've covered everything. So the first thing, you need to be familiar with your quadrants. Know the quadrants. So we need to know where all the different trig functions are positive and where they're negative in order to be able to determine which quadrants hold the solutions. We need to know what is the reference angle. Remember, we referred to that as alpha. What's the significance of alpha? We need to know how to factorize. We must be able to factorize a quadratic. Be able to factorize a quadratic. In a few of the earlier examples, it was very helpful for us to be familiar with the sine and cosine curves. It helped us to obtain solutions a lot faster. So be familiar with the sine and cosine curves. And the fifth, know your trig identities. Very important that we know them. The last 3 examples, I believe it was, they all came into play. If we didn't know them, we wouldn't be able to solve. So know your trig identities. Know your double angle formulae, and your compound angle formulae. Once you are comfortable with these 5 components, then you will be able to solve any trig equation. So know your quadrants, know the significance of the reference angle alpha, know how to factorize a quadratic, be familiar with what the sine and cosine curve looks like, and know that they vary between +1 and -1. Know your trig identities, your double angle formulae, and your compound angle formulae.